Hey there, I'm Darin. For the last 2.5 decades, and long before social media, I've been bringing Dassault Systems solutions to the masses, oftentimes using SOLIDWORKS to engineer a solution in my own life. This time, I'm revisiting a project I did 5 years ago, which was the springboard for much of the content I create today. It was one where I used SOLIDWORKS and 3D printing to integrate a 55-pound trolling motor onto my paddle wheel pontoon boat, giving it that traditional motorboat feel, but conforming to my lake rules prohibiting gas engines. And boy, did it work. Now, it's time to go bigger. Our first project will be to create a custom enclosure for this 24-volt, 3-gang switch panel with meter and USB ports. I'll begin in 3DEXPERIENCE SOLIDWORKS by modeling a few of my known elements, as I pretty much do with any creative project in my life. It doesn't take much time, but it pays big dividends in visualization as well as validating form, fit, and function as we go. The SOLIDWORKS we know and love is running on our desktop, but it's always connected to the 3DEXPERIENCE platform. And with just a couple of clicks, our data is uploaded to the cloud and available to anybody on our team with an internet connection. All right, this model could use a little more detail. Nothing mystical here, just straightforward multi-body modeling. But like I said, a little more effort here will ensure fit when we design the housing. All right, that looks good. Let's go ahead and update our model, and now it's time to really make some magic. We will easily switch over to a game-changing tool that models in a way that SOLIDWORKS simply cannot do: Subdivision modeling and 3DEXPERIENCE Sculptor. Now with a simple drag and drop, our SOLIDWORKS model is now available for reference inside of xShape, the design app for 3D Sculptor. Using sub-D bodies, we will concept our housing using free-form methods, and our easy and powerful robot gets the job done. Now, I'm not saying SOLIDWORKS can't create organic shapes, but when you have a purpose-built tool, the experience is really what matters. It takes some fine-tuning and manipulation, but it's actually kind of fun. All right, that looks great. Now, I want to maintain overall C2 tangency, but I'd like to crease this front face as well as a couple of edges, just to give them a little bit of a sharper blend. And I've got a couple other ideas I'd like to try. With the convenience of hassle-free data management that's built into your 3DEXPERIENCE, you can use one of my favorite features, branch and merge. It allows you to completely break off as many iterations as you'd like, so you can play around with concepts and what-ifs. And when you come up with a winner, just merge it right back in as the next revision. Now, draft analysis is a common step when the destination for these parts is the plastic injection molding line. But when additive manufacturing is involved, I'm much more interested in what faces will require supports. And the 3D printing capabilities on the platform give us that feedback immediately. Now I can tweak the design a little bit more to make sure that it will print within my necessary parameters. Now at this point, if you have access to the creator role and XDesign, we can just continue right along and finish with the mechanical elements. Or, if you're a SOLIDWORKS designer who is using Sculptor solo to benefit from sub-D modeling, feel free to complete the rest of the production level details back in your happy place. All right, I'm pretty satisfied with that. It's time to 3D print it. We're gonna send it to the MakerBot with some pretty aggressive settings here. I don't want anything touching those cosmetic faces. Seriously? Well, that's not good. Looks like I'm gonna need some help on this one. And I know just the guys.
Hey, what's up?
Hey man, I got a problem. You know those overhangs we talked about?
Yeah, how'd that turn out?
Well, you were right.
Okay.
Listen, I don't want anything touching these cosmetic faces. What do you got down there at the Pleasant Ridge office for me?
Yep, we have a couple of different technologies that we could try. The Origin one, which is the DLP resin printer, and then we could also try the powder bed fusion system, the SAF H350. And I think that one would be really good because it doesn't involve any support material.
Oh, that sounds perfect. I'm gonna send you a file. I'll be there tomorrow.
All right, fantastic, bye.
24 hours later, Simon's ready to remove the build from the H350. This process is very much like a giant push pop. Getting his first shot at this process, Richard Cromwell's going to step in and move the box over to the decaker. Finally, Ryan's going to take over to do the dirty work. It's the behind-the-scenes processing you don't see where the real heroes of additive manufacturing live.
Nice.
It's over to the media blaster for the final step in this process. And since Ryan did the dirty work, he gets the honors of the first fit up. The part texture also lends itself very well to paint and post-processing, and it's clear that I've chosen the right machine for this job. So with that, the stage is set for a series of videos where I'll integrate a heavily upgraded trolling motor, 24-volt electrical system, some really cool LEDs, and anything else awesome I can think of along the way. And I'll show you how I use the tools of my livelihood to get it all done. Until next time, I'm Darin at Go Engineer.